Hi everyone, my name is Giovanna Proença, and today we're going to talk about build a video game marketplace blockchain of freeCodeCamp Web3 course. So basically during this course we're going to learn how we can manipulate some crypto concepts. In this case in particular we're going to learn how to work with blockchains, but in the future we're going to learn other things as well as Rust, WASM in the context of a blockchain, so it's pretty good. Like you can see here we have multiple projects. I believe in total we have 17, but so far they only released 5, alright, like we can see in here. This will be our first project. Basically, in this project, we're gonna create a blockchain for a video game, and we're gonna be able to create users where these users can buy or sell items in this video game, okay? If you're not able to enter in this page, please watch our video explaining how can you set up your environment, because sometimes it can be a little bit frustrating. They have an instruction, but sometimes it doesn't work. So if you watch our lecture, our video, you will understand, okay? So without further ado, let's see what is a blockchain. A blockchain is a chain of blocks that contain information. You can think of blockchain as a list. The data which is stored inside of a block depends on the type of blockchain. For example, in the project we will work, a block contains information about the hash, previous hash, nouns, and transactions. The primary identifier of a block is the cryptographic hash, a digital fingerprint. A nouns is an abbreviation for number only used once, which is a number that we use to create the hash for the block in a blockchain. The previous hash is needed to maintain the chain of blocks in our blockchain. So basically a blockchain is a list, alright, that is connected with each other, and every element needs a hash that is a primary property where we're gonna see what is the fingerprint of that particular block. So it's a digital fingerprint of that particular block. We need to use the nouns that it's used to generate this hash that is encrypted, and we also need to keep track of the previous hash because we need to know what is the previous element of this element that we're working right now. So this way we can have a chained list. Okay, so this is pretty much what we're gonna work today, building this blockchain. Now let's see what are the files we have in our hands. So we have blockchain.json, that is the file where we're gonna store our blockchain. Right now it's empty, but we're gonna write by coding here using JavaScript how to generate this blockchain. This generate wallet is a file where we're gonna be able to create new users. So we're gonna write here some code in JavaScript to create new users. The buy item will allow the users to buy an item. The gift items we're gonna use in the future. We don't need to worry about this right now. The init blockchain, we need to create this file to generate the first block, and we're gonna see in the future. The items.json are the items that we have available in our marketplace. So these are the ones we can buy and sell, and here we have the price. The bind block here, this bind block file, we're gonna be able to create a new block in our blockchain. The sell item, we're able to sell the items, and the wallets.json will store all the users in our wallet, and transactions.json will store all the transactions. All right. Here is the simple browser where we're going to see the requirement. Basically, we're going to read the user stories to finish our problem. And in the end, how can we know that we passed the test? We're going to click in this button, run test, and we're going to see if we're passing in the test that we're checking. All right. Besides that, we have the blockchain helpers. That it's this file contains some functions that we're going to use. These functions are already implemented by freeCodeCamp, so we're just going to call them for the purpose of what we want. For example, this get blockchain, write blockchain, and so on. And then we have the example of transactions.json. So this is how it look like our transaction. This is how it will look like our wallet, and this is how it will look like our blockchain.json. All right. So these are the files we have in our hands. Now let's start with the first example. So in the first user stories, let's see. Your blockchain should be stored in blockchain.json, like we saw here. We're gonna store in this blockchain.json that right now it's empty. And see an example of blockchain.json, blah, 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 for an idea of how it should look. So basically, our blockchain will look like this, okay? If you see, all the other items, they are similar, but we have here the initial element that is a little bit different, and this is what we're gonna implement right now. You can initialize your blockchain by running node init blockchain. So the first file we're gonna write will be this node init blockchain. And in here, what we have to do, we should replace everything in the blockchain with an array that has one object, the genesis block. The object should have a hash property of 0 and a previous hash property of no. So basically we need to create this thing here that I'm highlighting. What is the genesis block? The genesis block is the first block in our blockchain, and we normally need to hard code. Do you see here that the hash is 0? So we're saying that this is the first element. And here for previous hash, we're saying no. No means that we don't have a previous hash. So we're creating the first block. How are we gonna do this? So let's follow the steps. Basically, they're telling us to create a new this genesis block using these properties, right? So let's start creating our object genesis block. So I'm gonna create here const genesis block. And to do this, now we're gonna create here, we need to add the two elements, the two properties that we're expecting in this object. So we're expecting to have a hash, and here we see hash object with property of 0, and 0 you see here in parentheses is string. So we're gonna have the number 0 inside of a string. And the second property here, it's the previous hash, so previous hash. And here we're gonna say no, that this is what they're expecting us to do. So far we have the block, all right, the first block, the Genesis block. Now we're gonna insert this Genesis block in our blockchain. So we're gonna use the right blockchains that you can see here in the first line. So what the right blockchain means. Basically, we're gonna call this function and we need to pass our blockchain. Remember that the blockchain is a list. So we're gonna send a list with only one element that is our Genesis block. And this way here, they're doing some things, but the main idea is that it's gonna write in our blockchain.json. So after creating our new block, I'm gonna say write blockchains, and we need to pass an array, so a list, where we only contain one item inside, that is the Genesis block. Okay, so far so good. So this is the first thing we need to do. Then here in the fourth item, when we run node init blockchain.js, we should replace everything in transactions.json with an empty array. So basically, every time we're creating a new blockchain, we need to clear our transactions.json, because this means that we're going to start everything from scratch. So if you see in here, we have a function called write transactions. And if we take a look in the write transactions, we're going to send a list again of all the transactions, and it will write for us in our transactions.json. So here, I'm going to call the function write transactions, and they're telling us to send an empty array here in the line in the item 4. So I'm just going to send here an empty array. Okay, so let's run and see what's going on. I'm going to open up our blockchain.json, and if I run node init blockchain.js and I click enter, we're going to see our Genesis block being generated. So if I click enter, now we have our Genesis block. And our transactions will remain empty. It was empty before, but now we're just hard coding that this must be empty. Okay? So now if we scroll down and run and test, we're going to see that we're passing the first two tests, that it's checking for the Genesis block and the transactions empty. Basically, the user stories will give us a guidance for the test that we're going to check in here. Okay? So the first two tests are made. Now let's go to the generate wallet. So now let's work with the wallets like I mentioned. So all the wallets names and their keys should be stored in wallets.json. So like we saw in the beginning, this is how it will look like our wallet. We have here it's a dictionary, right? And every element of our dictionary is the name of the user. Here it's me and you. And the value for this key pair, it's the public key inside and the private key. All right, so let's keep this in mind. When we should be able to create a wallet by running node generate wallet.js and the name that we want to insert of the user. So I'll be already writing this here, generate wallet.js, and I'm going to put G, but I won't click anything so far. Running node generate wallet.js, name should be added as a key in wallets, like we saw in here. It will be a key here in our wallets, all right, me. And here, with public key and private key properties. The value should be a public and a private key pair in hex format. Use the defined EC variable to generate the key pair. So what is this EC? EC is already something that we are importing, all right, that will help us creating this public and private key. And we're going to see here in the hints that they kind of explain to us how to generate a key pair, how to get a public and a private key from this key pair, okay? But let's start from the beginning. So basically, to generate a wallet, we need to get the private and the public key using this key pair. So we're going to start using these hints. Basically, to generate this, I'm gonna create a variable called const key pair, all right? And we're gonna use this ec.gen key pair function. So this will generate our key pair. Now we're gonna split this into public and private keys. So I'm gonna create here public key, and I'm gonna use the key pair dot get public. That is the function that we're working, and here they're telling us to use the hexadecimal structure. And then I'm gonna create a const private key. We're gonna use the key pair again, but now instead of getting the public, we're gonna get the private. Get private. Great. Now that we have the public and the private key, and if you see in here, we also get the name of the wallet using the command line argument. We need to create this new key value pair in our dictionary, right? And we know that the key will be the name of the user. Let me open up in here the wallet. We know that the key will be the name of the user, me, and the value will be the dictionary that we have inside. So first, we need to get our available wallet, and we can use this get wallet function. So here I'm going to create a variable called wallet, and I'm going to use this get wallet. So here we're getting all the available wallets, that is a dictionary, and now we're going to insert a new item in our dictionary. So to do this, we're going to say wallets, and like they mentioned, the property, the key for this new pair that we're adding is the name of the user. So we're going to use this variable new wallet name. And then we're going to store the value of public key and private key. Once we insert this new element, this new user in our wallet, we need to write this, we need to overwrite our wallets.json. We need to update our wallets.json file. So to do this, we're going to use this write wallets function. So here, write wallets, and we're going to send our wallets. Okay? This is pretty much what we need to do in the beginning. Now let's see the other parts of the requirement. So when you generate a wallet, it should push an object to the end of transactions.json array. The object should have a buyer address property of no, seller address property that is the public key of the new wallet, and price of 40. This is the game giving you some coins for buying items. So every time we're creating a new user, our video game is giving some coins for this user. So we're gonna create this transaction. We're gonna keep track of these transactions. We are sending 40 coins for this new user. Okay, so first let's get all the transactions that we have available. So const transactions, and we're going to store in our get transactions function. So this get transactions will get all the transactions we have stored in our transactions.json. Now we're going to push to the end of our transactions array. So every time we hear the word push, this means that we want to put in the end of the array. So here, before we do this, we need to create our new object that we want to push. So here, const new transaction. And like they are telling us, we want to create a transaction where we have buyer property of no. So let's create here buyer address will be no. The seller address will be the value of the public key of the new wallet, and we have this stored in our variable public key. And the price will be 40, a number, so we're giving 40 coins. After we create this new transaction, we're going to push this new transaction to the end of our array. So we're going to say transactions.push, and we're going to write here in the end of our array transaction. Great. This is almost finished. Now we need to update our transactions.json. So we're going to use this write transactions like we used it in the previous file. So write transactions, and we're going to send our transactions that is already updated. Okay? So let's see if it's working. In here, I'm going to open up our wallet. Okay, our wallet is empty and our transaction is empty as well. Here, I'm trying to create a new wallet with the name G. Once I click enter, now we're creating a new user G and the public and private key here. And in our transactions, now we have buyer address no, seller address, the public key, and the price of 40. So this means that it's working. Now let's run our test and check if it's working. So, like we can see in here, we passed these two tests for the generate wallet. Now we can move on for the next part. Now we're going to work with creating a mine, all right? We're creating a new block in our blockchain. So a block that is not the Genesis block anymore, now the other blocks in our blockchain. So running this mine block, we should create a new block in our blockchain, like we said. And basically we need the hash, previous hash, nouns, and transactions. So if we take a look here in our example blockchain, we're going to create now this property here, hash, previous hash, nouns, and transactions that is an array with the transactions. Okay, so this is pretty much what we need to do right now. Then, once we do this, we're gonna add this in our blockchain. Okay, and how we can get each property. So let's start with one step at a time. Basically, we're gonna create a new block, right? And I'm gonna write it down in here. What are the properties we need? So we need hash, we need previous hash, we need nouns, and we need transactions. Okay, these are the things we need. So let's start each at a time. So let's start getting the transactions. The transactions we're gonna get by the file transactions.json. So we're gonna use this get transactions. So const transactions, it's equal to get transactions. Okay, this is the first step, and I'm gonna write it down here, transactions. Then the hash and the nouns I will add for later. Right now, let's get the previous hash. So how can we get the previous hash? Basically, every time we're running in here, we need to get the last element, the last hash of our block. So we need to keep track what was the previous hash in the element that we're right now in the list. So to do this, let's get the last block first. So here const last block. And if you think we're working with a list, if we want to get the last element of a list, we can use the length -1, correct? So this is how we're going to access. So before, we need to create a variable to get the blockchain that we have right now. So I'm going to create a variable blockchain, and here get blockchain. So now we're getting everything we have in our blockchain so far. And now we're going to get the last element by using the position. So blockchain, and we want to get the element on the last element. So we're going to say blockchain.length -1. And let's see if it's working, okay? I'm going to do it here, console.log last block. And let's see if this is nice. So if I'm running here, node main block.js, and I'm gonna comment this out, otherwise we might have a bug. If I run this, we're gonna see that the last block is actually the last block that we have in our element, in our blockchain, all right? This is the last block, so we're getting here the last block. Now, how can we access exactly the previous hash? Since it's a dictionary, we can access by using the key of this pair. So if I do last block dot previous hash, we are supposed now to see no, okay? And if we click enter, now we're seeing no. So we're gonna use this, instead of using console.log, I'm gonna create a const saying previous hash. Okay, and we're gonna use this last block previous hash to get the previous hash. So right now we have almost half of, actually we have half of our new block. Okay, now we need to calculate the hash and the nouns. So if you take a look in here, basically the hash should be created using the define SHA-256 variable by concatenating the nouns, the hash of the previous block, and a stringified version of whatever it is, the transaction. So basically we have to calculate using this this function that we are importing from crypto.js, all right, to generate a new hash. Because if you remember, hash is our fingerprint, it's a digital fingerprint of our block, okay, so this needs to be encrypted. And basically we're gonna use nouns to find our hash. So one thing that we have to have in mind, the hash should start with at least 2 leading zeros. So we have to start with 2 zeros in the beginning, and then what is after it can be anything. And so basically we're gonna do a while loop to check, to find the hash that we wanna use that starts with this leading zero. So I'm gonna initialize our variable hash as a let, because I want this to be mutable. And I'm gonna create a let nouns equals to 0. Okay, then we're gonna do a while, and how are we gonna while? What will be our condition? When hash starts with 2 zeros, then we're gonna finish our loop. So with while hash is not equal to hash dot starts with 2 leading zeros, we're gonna continue looping. Once we have these 2 zeros in front, we're gonna stop our loop. Now we need to be aware of this. So increment your nouns to search for hash values until you find one. So basically we're gonna change the value of nouns first, and then we're gonna calculate hash. So here I'm gonna say nouns plus plus to change, to increment. And the hash now we're gonna calculate using this SHA-256. So you can say SHA-256, and basically like they're mentioning here, this is how we're gonna get our hash. We need to concatenate nouns, so I'm gonna put in here nouns plus previous hash plus Json, this is stringified version of our transactions. And after we find this hash, I'm gonna convert this number into a string, because remember that we initialize our hash as a string. And also because a number can never start with 2 zeros, only a string allows us to do this. So here, choose string, it will convert into a string. So now we have our hash and our nouns. This is great. And doing one thing, we are getting both. After we do this, we need to write our new block in the end of our blockchain. So here, we're gonna do blockchain.push to put in the end our new block. And we're gonna write our blockchain again in our blockchain.json. So here, write blockchain, and we're gonna pass blockchain. Okay? Just to finish this step, after mining a block, your transactions.json file should be an empty array. So after we do all of this, let's overwrite again our transactions, and we're gonna send an empty array like we did in the init block. All right, so let's see what it's looking like. So this is our blockchain. Once I wrote mine block, we should see a new block here. And this is telling us previous hash, cannot use it before. Let's see, previous hash, right, this is correct. I'm doing the while, let me cut, and I'm gonna put all of this before our while. Let's run it again and see what is going on. So node mine block, and now we're creating a new block with a hash, previous hash. No, oh, I made a mistake in here. It shouldn't be previous hash, right? The previous hash here should be the hash of the previous block. Okay, so let's start this again. I'm gonna remove it and I'm gonna run it again. So if I do mine block.js, the previous hash is 0 because we're getting the hash, not the previous hash. This is what I did wrong. The nouns here we find is 39. Here we have a hash, and our transactions in this case it's empty. Okay, so it's working so far. Now I'm gonna run the test and then we can move on. So like we can see here, we're passing the test, the known mine block, the 2 tasks that we have. Now we're gonna work with buy and then sell, and then we finish the project, okay? So for the buy here, we're gonna run node buy, so we're already writing here, node buy dash items.js. I think it's not by .item.js. We're gonna paste the private key of the user that wanna buy. So here I'm gonna copy the private key, and you're gonna put in the command line, and we're gonna say which item we wanna buy. So in this case, I will I will choose icon, okay? And this will be the structure to run this file. Then, when we buy an item, we should add an object to the end of our transactions.json array containing these properties. So we need to add who is the buyer, that is the public key of the user, the seller address, that will be null, the price that we purchased the item, and then we need to pass the signature that we're gonna generate. After we create this, we have to add in our transactions, but we will only add in the transaction if the user has enough money to buy the item. So we have a couple of things to see. This is an example of how it will look like. So basically here in the buyer address, we have the public key, the seller address, we have no price, item bought, and the signature, okay? So let's start creating this structure of the new transaction. So here const new transaction, new transaction. We're gonna create, we need the buyer address, we need the seller address, we need the price, we need the item bought, and we need a signature. One thing that is important is that the cell items will be pretty much the same as the buyer. So if we do this correctly right now, for the seller, it will be easier. So what is the buyer address? So let's take a look in here. Actually, let's start from what we know. We know that the seller address will be null. So here it will be null. We know that the item bought will be the name of the item bought. And here we already have a variable that is getting from the command line. So here we can use item bought. The price. So let's start getting the price. We can get the price by using the blockchain helpers, where we have this get item price. We send the item that we want to check, and it will return to us the value. So here, I'm going to create a const price, and we're going to get the price of this item. So get item price, and we can send the item bot that is storing the item that we want to buy. And here, I'm going to assign price. Now we need to get the public key. So if you take a look in here, we're receiving a private key, and with this private key, we need to be able to get the public, okay? So if you scroll down here in hints, we can get this get pair key pair from hex public key. This is not our case because we only have the private, so we're gonna use this get key pair from hex private key. So we're gonna use this info here, all right? So I'm gonna do a const key pair, and we're gonna use this ec.key from private, and we're gonna send the private key. So our private key is the buyer private key variable, and then we need to send hex. Okay, this way we're gonna get the key pair. Now with this key pair, we're able to get the public key the same way as we did when we were working with the generate wallet. So we're gonna use this part, get hex public key, using this. So const public key will be equals to key pair dot get private hex. Hex. All right, now we know that this public key will be our buyer address. So here, public key. Now we need to work with the signature, and the signature can be a little bit tricky because the signature should use the buyer's key pair to sign a concatenation of the buyer address, price, and item bought in that order in hex format. So basically, we're gonna sign using buyer, price, and item bought. So how can we sign? If we go here in the hints again, we have the sign information with key pair. So we're gonna use this. Okay, I'm gonna create here a variable const signature, and we're gonna use this key pair dot sign. We're gonna add something in this parenthesis, but right now I will let it empty. Dot to the hex. So we wanna use this signature, and it will be in hexadecimal. What we're gonna put here inside is this content to sign. They are telling us to use it in this order. We cannot use in a different order. Where it is? Here, buyer, price, and item bought. So here we know what is the buyer address. Oh, our buyer address is the public key, plus price, plus item bought. Okay, bought. So this way we are creating the signature, and we can add in here right now signature. Great. So we are creating our new transaction. What we need to do now, we need to check if the user has enough money to buy this transaction, right? So first, I'm gonna get all the transactions we have available. So transactions, and I'm gonna use the get transactions that we already saw, okay? And now, before we write the transaction, we need to check if the user has enough money. So basically here, they're telling us to use this get address balance. Let's see how it works. So the get address balance, where it is, the get address balance, we're gonna send the address of the user. So basically we're gonna use the public key, and we will be able to check if the user has enough money. Okay, so let's see how it looks like. If I do in here const balance equals to get address balance, and I paste the public key, that is our buyer address. Let's console.log balance and see what this is. All right, so if I run our code and click enter, we are not receiving anything because I didn't save the file. Let's run it again. And now we're getting that the user has 0. Okay, let's see what is happening here. So I saw what I was doing wrong. I was receiving here 0 because I was saying get private, but here it should be get public. So now if I run this, we're gonna get that the user has 40 coins. And we're gonna check if 40 coins is greater than the price, we're able to buy the transaction, to succeed the transaction. So this is what we're gonna say. If balance is greater or equals to price, we're able to succeed this transaction. So we're gonna push this new transaction in the end of our transactions list, so new transaction. And then we have to write in our transactions.json again. So here write transactions and we pass transactions. Okay, this is pretty much what we need. So let's see. So far, our transaction is empty. But now that I'm gonna buy and I click enter, now we have the buyer address, seller no, price 10, item bought icon, and we have our signature. So I'm gonna run the test, check if it's working, and then we continue with the sell. So like you can see here, we passed the test for buy. Now we need to do the sell. That will be exactly the same, but the other way around. And what do I mean with the other way around? We're gonna run the file the same way, but now this is the structure of our object. The buyer address right now will be null, not the public key anymore. The seller address will be the public key, so we change here. The price will be 5 coins less than the purchase price of the item. So we're gonna get the value of the item, and we're gonna subtract by 5. The item sold, now instead of item bought, it will be item sold. And the signature, we're gonna calculate the same way. All right. So for the buy, I'm gonna copy exactly what we did in here, and I'm gonna paste and do some changes. We also need to do one extra change in the end, but I will tell when the time comes. So here, public key, public key. Now it's not buyer private key, now it's seller private key. So here's seller, this is the variable we have available. The price is not the price of item bought, it's the price of item sold because we changed the variable. And remember that we have to subtract by 5 coins. Okay, here now we need to change. The signature will remain the same. Now the buyer address is null, and the seller address will be the public key. The price will be price. Here is not item bought anymore, it should be item sold. And the signature will be the same. Now, we're not gonna check the balance, how much money the user has. Now we need to check if the user has that particular item that he's trying to sold. So this won't be our if statement anymore, and this will be changing this if condition. The other parts will remain the same. So how can we check what is if the user contains the item? We can use this get address item. Basically, if we run this get address item, I'm gonna create here const items, get address items, and I'm gonna send the public key. With this public key, we are able to check what are the items that particular user has. So in that portfolio, so here console.log items. And let's see, I'm gonna comment this out because we need to check some things. So if I run in here, instead of node buy, it will be node sell item, okay? And you have to use the private key again, so here's sell item. And I click enter. There's something wrong, item bought. Here it's item sold. Every time we have item bought, it should be item sold. Let's run this again. And here we're getting all the items that this particular user has. And we know that he has only one icon. So in this case, we need to check if items on position of the item sold, we have that particular item. So in item sold here, we're checking for icon, right? So if we take a look, it will turn as number 1 because we have one icon. So if we have at least one icon, one element to sell, we are able to succeed in this transaction. Otherwise, we're trying to sell an item that we don't have. So this is what our if statement will check. So if item sold is greater or equals to 1, this means that we're able to do this transaction. Okay, let me remove the comment out. So let's see, I'm gonna open up here the transactions.json, and I'm gonna run here again the same function. And now we have the transaction for the sell. So the buyer address now is null, the seller is the public key, the price is 5 coins less than the usual price, item sold is icon, and the signature is working. Okay, so now let's run the test, and basically about coding we finished. Now we just need to complete the other tests by running some commands in the terminal, but we're gonna do this together. So like you can see in here, we passed the true test for sell, so like I mentioned, we're done with the code. Now we need to pass this other test. So basically, now we're gonna insert some data in our code, okay? They are telling us to have at least 3 wallets in our wallets.json. So far I only have 2. So you should run node generate wallet and the name of the person you wanna generate. So here I'm gonna create some others. Anna, for example. So now we have other at least 3 wallets. Then we need to have at least 10 blocks. So right now in our blockchain, I have 1, 2, 3, 4. Now I need to generate more 6. So you should do node mine block.js and it will generate for us. Okay, 6, 7, 8, 9, 10. So here it's generating the blocks for us, okay? Then you should have at least 20 transactions, and in these 20 transactions, 10 should have signatures. So how can you do half of these transactions? We're gonna use these gift items, okay? Because the gift item will give one free item for each user we have in our wallet. So basically here I'm gonna do node gift items.js, and it will give one item for each user. Since we have 4 users, now we have 4 transactions. If I run again, we're gonna have 8, and if I run again, now we're gonna have 12. So if we run the test, we're passing at some point here in the run test. And to finish, to complete, we need to have 10 transactions with signatures. So right now you can play around with buying and selling some items. So I'm gonna say here, for example, buy item, and let's see the transaction if we are incrementing here in our transaction. So I just try to buy a item. Oops, here. I'm gonna buy again. I'm gonna buy again for the same user until we're not able to do this anymore. Okay, we weren't. So now I'm gonna sell these items that I just bought. And you have to do this a couple of times until you have 10. Okay, so now we're not able to sell anymore. I'm gonna buy again. I'm gonna sell again. I'm gonna try to buy again, and I was able, and I'm gonna sell again. Here you can do your user imagination, but I'm just doing this randomly so we're able to finish the tests. And when we succeed everything, it will appear that we have, it won't work right now because in the end we need to do node mine block.js to restore these transactions that we did. Okay, so we're not having anything else in our transactions.json, but now it's stored in our blockchain. Okay, so remember to run this node. After you run this node mine block.js, now I think we will succeed in all of the files. Or if we're missing at least one transaction or the other, but we will see soon. And like we are seeing here, congratulations, you passed all tests. So this is pretty much what we needed to do for this project. I hope you enjoyed this content. Please give us a thumbs up, subscribe to our channel. If you want to know more about this course of Web3 and learn more about crypto, please follow us and you're going to learn a lot, okay? I hope to see you soon. Take care, bye-bye. If you would like to have full support from programming expert via Telegram group and group coaching, check the description below.